Hi there, welcome back to Think Tank Online Learning. In this video, we're going to talk about Thevenin Theorem. So we're given a circuit, we have 100 volts power source, 10 ohm resistor, 20 ohm resistor, 12 ohm resistor, 8 ohm resistor, and 100 ohm resistor. Okay, so we want to find the current that is passing through the 100 ohm resistor. So we're going to use Thevenin Theorem. So what we want to do, want to reduce this circuit into a Thevenin equivalent circuit where we have the voltage, Thevenin's voltage, we have Thevenin's resistance, and we're going to put our load resistor. In this case, 100 ohm resistor is the load resistor, and after that, finding current is going to be E, so we're just going to use V equals to R, and we have our voltage, and we have two resistors which are connected in series, so we're going to just add these two resistors, and we're going to find the current by simply saying current equals to Thevenin voltage divided by Thevenin resistance plus the load resistor. Okay, so first of all, what I'm going to find, I am going to find the Thevenin's resistance, then after that I'm going to find Thevenin's voltage. Okay, so now to find Thevenin's resistance, I'm going to write here Thevenin resistance. Okay, so first of all, we should be familiar with identifying that whether the resistors are in parallel or resistors are in series. So as you can see, what I'm going to do first, we're going to remove the load resistor, and after that we're going to remove power source. So we replace the voltage source with a short circuit. If there was any current source, we would replace that with open circuit. Okay, so now what I'm going to do, I'm going to redraw this circuit. We set voltage source with the short circuit, and I'm going to write the 100 ohm resistor, 20 ohm resistor, 12 ohm resistor, 8 ohm resistor, and I'm going to remove the load resistor, 100 ohm resistor. So I'm going to have terminal, I'm going to call this terminal A, and I'm going to call this terminal B. Okay, we still have our resistors, just remove the 100 ohm resistor. So we have 10 ohm resistor here, 20 ohm resistor here, 12 ohm resistor, and we have 8 ohm resistor. So you should be familiar with identifying which resistors are connected in parallel and which resistors are connected in series. Okay, that is going to ease our work. Okay, so now to find the Thevenin resistance, it doesn't matter which side we start with. Okay, so now if we have current, I'm going to say, let's say we have current, we have I1, let's just call it I. Okay, so this current is going to split, so we're going to have I1 here, and we're going to have I2 here. Okay, so if resistors have different current, that means those resistors are connected in parallel. Okay, so that means the 12 ohm resistor is connected in parallel with the 8 ohm resistor. Okay, but before calculating the total resistance here, let's see. Okay, see, we have I2 current, okay, and I2 current is going to split, so I'm going to have I3 current here, and I'm going to have I4 current here. So as you can see, I4 and I3 are different, so that means the 10 ohm resistor and the 20 ohm resistors are connected in parallel. Okay, but if we add I4 and I3, we're going to get I2. So that means the 10 ohm resistor and the 20 ohm resistor are in series with the 12 ohm resistor. Okay, so now what we're going to do, we're going to say Thevenin's resistance, RTH, is going to be, okay, we said the 10 ohm resistor is in parallel with the 20 ohm resistor. Okay, but these two resistors are in series with the 12 ohm resistor. Because if we have this current, we're going to get I2. So we say this one plus 12 ohm resistor. Now you see that I2, all these currents, I3 and I4, if we them are going to get I2. Okay, so that means all these resistors, 1, 2, 3 resistor, they're in parallel with the 8 ohm resistor. Okay, so what we have something like this. Okay, I think now we can calculate the total resistance. Okay, so for resistors which are in parallel, resistance is equal to product over sum. Okay, so now let's find the total resistance. So we're going to say 20 times 10 divided by 20 plus 10, and we're going to have 200 divided by 30, okay? And we're going to say 200 divided by 30 plus 12. And what are we going to get? If say 200 divided by 30 plus 12, we're going to have 56 remainder 3, okay? We're going to have 56 remainder 3. Again, we've said all these resistors 1, 2, 3, then parallel with the 8 ohm resistor. So I'm going to say 56 is in parallel with the 8 ohm resistor. So that means the total resistance is going to be 56 over 3 times 8 divided by 56 over 3 plus 8. And what are we going to get? If we say 56 remainder 3 times 8 divided by 56 remainder 3 plus 8. Okay, so the total resistance is going to be 5.6 ohm. Okay, so that means now we have RTH, which is the Thevenin resistance, that is equal to 5.6 ohms. Now, want to find the voltage. Okay, the voltage at the terminal A and B. Okay, so you should know that if two resistors are in parallel, that means they will have the same voltage. If resistors are connected in parallel, they will have the same resistance. Okay, so now I'm going to put back the voltage, the voltage source, but I'm not going to include the load resistor. So here I'm going to say for voltage, Thevenin's voltage. Okay, so I'm going to draw our power source, 100 volts. We have the 100 ohm, the 10 ohm resistor, we have the 20 ohm resistor, we have the 12 ohm resistor, and we have the 8 ohm resistor. And we have terminals. We say this is A and this is B. Okay, so this is the 10 ohm resistor. We have 100 volts here, and we have 20 ohm resistor, and we have 12 ohm resistor, and we have 8 ohm resistor. In order for us to find the voltage at this terminal, so what I'm going to do, I'm going to put a resistor here. So I'm going to put, let me put this resistor in red. I'm going to say we have 0 ohm here. Okay, that is same as saying there's no resistor. Okay, so now what is going to happen here? We are going to have a voltage drop here, a voltage drop here, and a voltage drop here. So the voltage at this point, if you find the voltage at this point, is going to be the voltage at the terminals A and B. Because again, see, the voltage that is passing through the 8 ohm resistor is also equal to the voltage that is passing the 0 ohm resistor. We have said if resistors are connected in parallel, then we have the same voltage. Okay, so what is the best way to find the voltage? You can use nodal analysis, but I'm going to use Kirchhoff's voltage law. Okay, so now I'm going to say this is I1, the current that is flowing the loop 1. I'm going to call this loop 1. Okay, let me just call it loop 1. And this is the second loop, loop 2. I'm going to call the current that is flowing this loop I2. Okay, so remember we have no current here because we have an open circuit here. Okay, there won't be any current. Okay, so if you find I2, the current that is flowing through the 8 ohm resistor, it is going to be very easy to find the voltage because you know that voltage equals IR, and you say the voltage that is the voltage on the 8 ohm resistor is going to be equal to the voltage on the 0 ohm resistor, and that is the voltage on the terminal A and B. Okay, so now considering loop 1, I'm going to use mesh analysis. We have the voltage source 100, and we have two resistors 10 and 20. So I'm going to say 10 plus 20, that is going to give us 30 I1. Okay, but we have the 20 ohm resistor which is sharing current. It is also found in loop 2. So I'm going to say minus 20 I2. So if you are not familiar with the mesh analysis, you can check. I have a video which explain how to use mesh analysis. I think it is going to be easy. So that is equation number 1. Now I'm going to consider loop, the second loop, loop 2, still using Kirchhoff's voltage law. Okay, look, we have no power source here, we have no voltage source, so I'm going to say 0 is equal to, how many resistors do we have? We have 12 plus 20 plus 8, and that is going to give us 40 I2, but 20 ohm resistor is also found in loop 1, so I'm going to say 20 minus 20 I1, and that is going to be the second equation. So if we solve this equation simultaneously, we're going to find I1 and I2, but you should remember that we're only concerned with I2. Okay, so this equation number 1, if we divide each and every term by 10, what are we going to have? We're going to have 2 here, we're going to have 3 here, and we're going to have 10 here. So that means our new equation is going to be 10 is equal to 3I1 minus 2I2. That is equation number 1. And for equation number 2, what are we going to have if we divide each and every term by 10? We're going to have 2 here, and we're going to have 4, and on 0, we're going to have 0. Okay, so and if we make I1 side of the formula, what we're going to have, we're going to see, okay, I think we can divide this equation by 2. So if we divide this equation by 2, what we're going to have, we're going to have 1 here, and we're going to have 2 here, and we're going to have 0 here. Okay, so the new equation is going to be I1 is equal to 2I2. That is equation number 2. I think these are the simultaneous equations that we can obtain from these equations. Now what I'm going to write, solve 1 and 2 simultaneously. So by substituting I1 into equation 1, we're going to see that 10 is equal to 3. Instead of writing I1, I'm going to write 2I2 minus 3I2. Okay, actually it's 2I2 here. Okay, minus 2I2. Okay, so we have 10 minus 6 minus 2. So we're going to have 10 is equal to 4I2. And we divide each and every term by 4. What we're going to have, we're going to have I2 is going to be equal to 2,5 amps. Okay, you can go on and find I1, but you don't need I1 because we're concerned with the current that is passing through the 8 ohm resistor. Okay, so now for the 8 ohm resistor, let me write here for the 8 ohm resistor. For the 8 ohm resistor, what do you know? We know that voltage is equal to IR. So that means voltage is going to be, what is the current? 2,5 times the resistance. And the resistance is 8. And if we say 8 times 2,5, I think that is going to give us 20. Okay, so now we have the Thevenin voltage, 20 volts. And we have the Thevenin resistance, 5.6, and we're going to just put our load resistor. So what is going to be our new question? So we have the voltage source, we have the Thevenin resistance here, we have the load resistor, which is 100 ohms, and what is the Thevenin resistance? We said 5.6 ohms, and we have the voltage, Thevenin voltage, which is 20 volts. Okay, so now to find the current that is flowing through the 100 ohm resistor is going to be is, so current is equal to, what is the Thevenin voltage? Okay, which is 20 divided by the load resistance plus the Thevenin resistance, that is going to give us 5.6 plus 100, and we're going to get our current. So if we say 20 divided by 5.6 plus 100, the answer is going to be 0.189. So this is all about the Thevenin theorem. Don't forget to subscribe, share, like, and comment.